This activity 1, start with a series circuit. Series is only one path, like one loop. In parallel is multiple. The series circuit, just one battery, 2 bulbs. This is what it should look like. One battery, 2 bulbs. Here's our parallel where we have 1 battery, 2 bulbs as well, but they're on separate pathways. I have you measure current with a ammeter. This one, remember, current is a rate of charge flow, or like how quickly the electrons are traveling. Even just looking now, you can see how slowly these things are moving. You can barely tell. And then if I go over here, these are obviously moving faster, and you could see that there's a greater current reading of 1.8 amps. And measure all around the circuit. The current is everywhere the same. It's 0.45 amps. Current is everywhere the same along a single pathway because they can't clump up or disappear or whatever. So they all have to move at the same rate, like a bunch of people walking in a line. Record the voltage being provided by the battery. So to do that, you can do it a couple different ways. One, just click on the battery and it'll tell you right there, 9 volts. You could also use the voltmeter. And have you add another bulb in series. So you just click on that, click to cut it, added another bulb. In series means like in the same line as, in the same loop. So it's all still in the same loop. And you should notice the current gets slower, the electrons moving slower, the lights are dimmer. And look at our current reading now. It went from 0.45 to 0.3. And why is that? Well, because now we have 3 resistors, because light bulbs are resistors. Now we have 3 in the same line. It's like adding way too many people in a single line to move tennis balls. It's like, imagine instead of going through a checkout with 1 cashier, you have to go through a checkout with 3 cashiers in a row. Current went down, the brightness went down. We add another resistor in series. Now, parallel, measure the current that's flowing through wire A, where the charges are exiting the battery, or what I call the main line. This current that we're going to measure is going to be considered the total current because the total current flows through the main line. This is actually the main line right here. It's the lines that go to and from the battery directly before they are either split up or like brought back together again. As you'll find out, like for the most part, circuits like these are symmetrical. So whatever you have over here is the same as over there. Here, same as there. Current here is equal to the current there. It's just like mirror versions of each other. Location A, we have a current of 1.8. The current flowing through wire B, the wire that leads up to bulb 1. Current is 0.9 amps. Location C, it's going to be 0.9 as well. Include your units. This is 0.9 amps and then 0.9 amps. And then location D and wire D, where the charges are entering the battery, or at this location here on the other side of the battery. See, look, on the one side of the battery, it's 1.8. Should be, since it's on the same pathway, it should be the same, 1.8. You know, it can't change from there to there. It can't slow down because that would cause them to clump up. It can't speed up because that would cause them to spread out. So it's 1.8 all along this main line. That's the total current. And then it's going to be 0.9 all along this line. And then 0.9 all along that line, those separate lines. 0.9 plus 0.9 gives you 1.8 total. This is 1.8 amps. It's just, the point is, like, we have 2 pathways. So this total current is going to be split in half evenly. And that only happens when you have equal resistance among your resistors, which we do in this by default, and we'll assume here, because otherwise it gets pretty complicated. So 1.8 divided by 2 is 0.9. Right, so you get 0.9 and 0.9, and then they add back up. 0.9 plus 0.9 gives you back to 1.8 again. So if I add, like I have you in the next section, have you add a third pathway with an identical resistor on it. This is like adding a third line of people moving tennis balls. It's like opening up a third cash register, a third toll booth. The heck? You're going to now triple your production. You're going to increase the total. The total is going to increase. It's like adding 3 lines. You guys know that 3 lines of people moving tennis balls is better than 2, which is better than 1, and so on. We had 0.9 and 0.9 per pathway. Notice it's still the same because the line of people are still the same. You know, just because we add a third line doesn't make the people in the other 2 lines perform any faster or slower. So they're going to still do the same job they did before. And electrically speaking, you know, these resistors are still the same. So the current is going to still be the same along that pathway. So now we got 0.9, 0.9, and our third line is also 0.9. It's like we duplicated our line once more. for a third line. So 0.9 plus 0.9 plus 0.9 makes a total current of 2.7. So our total has increased. It's gone from would have gone from 0.9 to 1.8 to 2.7. So you might be seeing what's going on here. Every line, if we were to add a fourth line, it would add another 0.9 amps to the total, bringing it to 3.6. You got 2.7 amps. Once it gets here, a third drops off. 2/3 continues on. Another third drops off, and then the last third carries on to the third pathway. So that total current gets split evenly between your separate pathways. I'm going to have to do another part